I'm going to show you how to derive an equation linking the decay constant and half-life, and you need to be able to do this derivation for the exam. So let me explain. So we start off with this equation here again, n equals n naught e to the minus lambda t. And we know that when t equals t half, we know that when that's the case, n is equal to n naught over 2, because the number, when one half-life has taken place, when time has elapsed to the point that we've been through one whole half-life, we know that the original number of radioactive nuclei has halved. Okay, so we know those things are correct, and we can substitute those into this equation. So we can get n naught over 2 equals n naught e to the minus lambda t half. Okay. Now we can then divide both sides, divide through by n naught. Okay, so divide the whole thing through by n naught, and we're going to get half equals, whoops, that's wrong, half equals e to the minus lambda t half. Okay. Now, really important to be aware here of a mathematical principle. A to the minus x is equal to 1 over a to the x. So therefore, we know that 1 over 2 equals e to the minus lambda t half is the same as 1 over e to the lambda t half. Okay. So then we can further rearrange this equation to give us this. E lambda multiplied by t half equals 2. And then we can natural log both sides. Now, this is important. We've seen before, okay, so we know that's true. We've done that. We know that e to the power of a, or the natural log of e to the power of a, is equal to a. Because remember, we're saying here, what power do we have to raise e to get e to the a? Remember, another way of writing this is log to the base e to the a, which equals a. What power do we have to raise e to get to e to the a? Well, we have to raise e to the power of a. Okay, so when you natural log e to the a, you just get a. So when we're going to natural log both sides here, ln e is equal to ln 2, but we know that when we natural log that, we just get okay. Then there's one final step here, and it's this. From this, we can just rearrange to get lambda equals ln 2 over t half. Okay, and remember, t half is a half-life in seconds, and lambda is equal to the decay constant in seconds to the minus 1. Okay, so this equation here, you need to be able to derive this equation from this equation in the way that I've just shown you. So you need to be able to go through those mathematical steps. What the question will probably be is, show that this is the, use this equation to show that this is true, or they might just ask you to derive this equation from this equation. And when you do that, you need to show all of the steps. But it's important you show the steps clearly, because that's where your marks will come from. Now, this equation here is in the data book, so worth being aware of that. But that's how you derive this equation from this equation.